Hello and welcome back. Today will be the third and final tutorial on open-ended AICs Type II. We fully reviewed the basics for AICs Type II at the beginning of video number 35, so I won't bother repeating all of that here, okay? If you recall from that video, there are three possible outcomes or cases for these AIC Type II chains. Today we will examine case C, where we will have identical bi-value cells on each end of the chain. These are by far the most desirable and productive kinds of these type II chains, and you should strive to find them whenever you can. But before we go to the examples, let's take a look at the different ways these endpoint cells can function as the first or the last cell of the chain. Now remember, an AIC Type II will always begin and end with different digit candidates that lie in two cells that can see each other, i.e. the two cells must be in the same house, and so they can be in a row, a column, or a block. But for convenience sake, here in this diagram, we will be using the rows only, okay? Now please use your imagination, and let's say we have an AIC Type II with the endpoint cells in row 1 here and here. And likewise, let's say we have another one with the endpoint cells in row 3 here and here. And another one in row 5, and another one in row 7. And let's say each of these chains begins with the 7 and ends with the 3, like this. 7, 3, 7, 3. Now there are four ways to link up those endpoint cells to the intermediate links in the chain that I want you to imagine are snaking all over through the whole puzzle. But we just want to focus on these endpoint cells right now. Now the first way is for there to be a strong link coming off of this 7 right out of the cell and bypassing the 3, and in the last cell a strong link coming into the cell on the 3 and bypassing the 7. The second way is for there to be a strong link to that 3 as the first link of the chain, and then a weak link coming out of the cell. And then just like the first example, there can be a strong link coming in on the 3, bypassing the 7. And then the third way is for there to be a strong link coming off of the 7 straight out of the cell, bypassing the 3, and then for the end to be a weak link coming in to the 7, and then a strong link going to the 3. And then the final way is that there will be a strong link between the 7 and the 3 in both cells, with the weak link coming out of the first cell on 3, and in the last cell, a weak link coming into the 7 with a strong link going to the 3. Now this fourth one is probably the least common of them, but it does happen, as you will see later. And because we know we can eliminate the start digit from the end cell and the end digit from the start cell, and these are all identical bi-value cells, that means we're going to be able to eliminate the 3 from every one of those start cells, and we're going to be able to eliminate the 7 from every one of those end cells. Okay? Just like this. Now when you have the first link coming straight out of the cell and the last link going straight into the cell, those two candidates that you're going to eliminate are just freestanding candidates, and they're just normal eliminations. But whenever the first or the last link is within the two candidates in the bi-value cell, like you see here in row 3 and in row 5 and in row 7, the candidate that's eliminated is part of the chain, and this is another example of cannibalism. Every one of those circled candidates is going to be false, and that's going to leave a naked single in each one of those cells, which means the strongly linked endpoint candidate in each one of those chains is going to be the solution to that cell. Like here in row 1, this 7 is going to be the solution to that cell, and this 3 is going to be the solution to that cell. And likewise in row 7, the 7 will be the solution to this cell, and the 3 will be the solution to that cell. Now, if you remember from the last video, the start digit does not always occur in the end cell, and the end digit does not always occur in the start cell. For instance, if we had an AIC Type II that began with this candidate 9 with a strong link coming out of that cell and ended with a strong link going into this 3 on that cell, The end digit does indeed appear in the start cell, so you could eliminate that 3. But since there is no 9 in this cell, there's nothing you can do here, and even though it's a bi-value cell, you cannot solve the cell. The only thing you could do in this situation is eliminate this red circled 3. But when you have two identical bi-value cells, that start digit is always going to appear in the end cell, and the end digit is always going to appear in the start cell. So you will always be able to enter the strongly linked endpoint candidates into those cells as the solutions to those cells. And that's the beauty of this configuration. Now down here in row 7, we have two identical bi-value cells, and they could be the endpoints of an AIC Type II. Now don't forget, this is also a naked pair because you have two identical bi-value cells that lie in the same house. That's always going to be the case for an AIC Type II that begins and ends with identical bi-value cells. So before you do anything else, you know that you can eliminate all the 8s and all the 2s from that row or from whatever house they happen to lie in. But because an AIC Type II has to begin and end with different digit candidates, it's never going to be the case where the 8 is the start digit and the 8 is the end digit, because that would be an AIC Type I, and it would also be a continuous loop, which we will be covering very soon in tutorials number 39 and number 40. Okay, let's take a look at some real examples and some real puzzles. All right, here in this puzzle, we have a naked pair of 1 and 5 up here in row 1. So we know that one of those cells must contain the 1 and the other cell must contain the 5. But at first glance, we don't know which is which. Now, as you can see, all the other cells in row 1 are already filled in. But even if they weren't, if we saw those two identical bi-value cells in any house, i.e. a row, column, or block, regardless of how many other cells in that house were filled in, we would know that one of them has to be the 1 and the other has to be the 5, right? That's how a naked pair works. But if we can connect those two cells with an AIC Type II, we will know which is which, because we will be able to immediately solve both of those cells. And this is huge, okay? So remember, the chain has to begin and end with a strong link, and it has to begin and end with different digits. So it will either start with the 1 and end with the 5, or it will start with the 5 and end with the 1. And it doesn't matter which cell you start on or which direction you go, because the chain will be reversible. So let's take a shot and start here on this 5 and see what happens. Let's make a strong link to this 5, a weak link to this 5, strong to the 2, a surrogate weak link to that 2, that's a strong link being used as a weak link in the chain, then a strong link to the 1 in that bi-value cell, a weak link to this one, and finally a strong link to this one up here in row 1, column 9. So we've got it, and here's the chain. And because of this chain, we know that the start digit cannot be true in the end cell, and the end digit cannot be true in the start cell, which means that these two candidates must be false. That's the start digit in the end cell, and this is the end digit in the start cell. Okay? And that will leave a naked single in each one of those cells. But let's take a closer look at what's really going on here. Because of this perfectly constructed AIC, we know that there is an effective strong link between those two endpoints, meaning that if either one of them is false, then the other one must be true. Let's go through the logical inferences of this chain and check that. Remember that because we are starting with a strong link, we always assume the first candidate is false. If A is false, then B is true. This is the definition of a strong link. So if this first 5, this blue 5, is false, the yellow 5 would be true. And if that 5 is true, this 5 would be false. If this 5 is false, the yellow 2 would be true. And if that yellow 2 were true, the blue 2 would be false. If that blue 2 is false, the yellow 1 would be true. If the yellow 1 is true, this one would be false. And finally, if this one is false, the yellow 1 up here in row 1, column 9 would be true, and that would be the endpoint of our chain. So let's look at the two possibilities for this blue 5 up here in row 1, column 2, which is the starting point of our chain. If this 5 is false, we know that because of the chain of inferences that this yellow one over here in row 1, column 9 must be true, which would negate this red colored 5. And if the blue 5 over here were true, that would also negate this red colored 5 because there can only be one 5 in that row. So this red 5 is false either way and can be eliminated. And that would leave a naked single on this candidate 1, and we would know that's the solution to this cell, and you can fill it in just like that. But let's go back. Now we could go through the logic again starting on this 1, but we don't really need to do that because as soon as we know this cell is a 1, we know this other cell must be a 5. That's the only way it can be with a naked pair. But let me show you something interesting about the logic here. If this blue 5 is false, then the chain tells us that this yellow one is true, right? And that would further mean that this red 5 is false. So you may say, well, wait a minute. If the blue 5 is false, then the red 5 would also have to be false, which means there would not be a 5 in row 1. Both 5s would be false. How can that be? Well, here's the explanation. Remember, we are dealing with conditional statements, not facts. We use these conditional statements to help us make logical deductions. And if you recall from previous lessons, when a premise leads to a contradiction or an impossibility, then the premise must be false. Let me repeat that. When a premise leads to a contradiction or an impossibility, then the premise must be false. This is one of the most important concepts for you to understand, especially when we start talking about discontinuous loops and forcing chains, for instance. So our premise was, if the blue 5 is false. And this premise leads to an impossibility, i.e. that there is no 5 in row 1. And we know that this cannot be possible. So we can safely conclude that our premise was false. And if our premise of the blue 5 being false is false, then we can safely conclude that the blue 5 is true. Capiche? I hope that's clear. And another peculiarity to notice is this. Remember that I have always made the distinction between a conventional strong link and an effective strong link. Now, if you don't know what I'm talking about, please go back and watch videos number 3, number 4, and number 33. And I have always said that in an effective strong link between the two endpoints of an AIC, Type I or Type II, if either one of the endpoints is false, then the other one must be true. But this does not preclude the possibility of both endpoints being true. In a conventional strong link, it is impossible for both candidates to be true. But with an effective strong link, it is possible for both candidates to be true. And I've got news for you. Whenever you have an AIC Type II with identical bi-value cells on each end like we have here, it will always be the case that both endpoints are true. Is that cool or what? Because as we just saw a minute ago, if you try to assume either one is false, it will lead to an impossible situation. So when you see a configuration like this, you can waste time and eliminate those two red-colored candidates, knowing that the start digit cannot be true in the end cell and the end digit cannot be true in the start cell, leaving two naked singles, and then you can fill them both in. But let's go back. Or you can cut to the chase and immediately enter the two strongly linked endpoint candidates into their cells just like that. Piece of cake, right? All right, let's go to the next one. All right, here we have a naked pair of 5 and 8 in block 5. Two identical bi-value cells that lie in the same house. So let's start here on this 8 and make a strong link to this 8, weak to the 9, strong to that 9, a surrogate weak link to that 4, a strong link to that 4, a weak link to the 5, and finally a strong link to that 5. So we know the start digit cannot be true in the end cell, so that 8 is false, and the end digit cannot be true in the start cell, so that 5 is false. Now remember, this yellow 5 and the blue 8, which are the endpoints of our chain, they do not technically see each other because they lie in different cells. Remember, for two different digit candidates to see each other, they must lie in the same cell. But these cells see each other, and that's all we need. So we know when we have two identical bi-value cells that are hooked up with an AIC Type II, we can immediately enter those two strongly linked endpoint candidates into their cells, just like that. Okay, let's go to the next one. All right, here in this puzzle, we've got a naked pair of 7 and 5 in column 6. And we have an AIC Type II of 15 links, so stay with me here. We're going to start on this 5, strong to the 5, weak to the 9, strong to that 9, weak down to this 9, strong to the 3, then weak down to this 3, strong to the 4, weak to this 4, strong to the 9, and then a surrogate weak link to that 9. And then we're going to make a strong link up to this 9. And then we're going to use 7s the rest of the way. We're going to make a weak link to this 7, a strong link to that 7, a weak link to that 7, and a strong link to that 7. So we know these two candidates must be false, which means we can enter the endpoint candidates into their cells as the solutions to those two cells. But let's go back and draw the chain. So there's the chain, and if you would like to examine it a little more closely, just stop the video. That way we can keep going. All right, let's go to the next one. All right, this time our naked pair lies in two houses at the same time, column 4 and block 2. And this time the first link of the chain is going to be within this bi-value cell. We're going to make a strong link starting on that blue 5 and going to the yellow 6, okay? And we all know what that means. So now we're going to make a weak link to this 6, strong to this 6, weak to the 2, strong to the 2, weak to the 1, strong to this 1, weak to the 4, strong to this 4, weak to this 4, strong to the 6, weak to this 6, and finally a strong link to that 6. Now notice the 5 is the start digit and the 6 down here in row 2, column 4. This yellow 6 is our end digit. Even though they're both yellow, this one in row 2 is the end point. So let's draw the chain. Okay, remember our first link is a strong link within this cell from the 5 to the 6, and then we've got a weak link over to this 6, and then we've got a strong link down to this 6, so let's do it like that. And then we've got a weak link to the 2, a strong link to this 2, a weak link to the 1, a strong link over to this 1, a weak link to the 4, a strong link to this 4, and then a weak link up to this 4. Remember, the weak links are green and the strong links are blue. So we've got a strong link over to this 6, a weak link up to this 6, and finally a strong link over to this 6. So we'll do it like that. So now, even though this yellow 6 up here in row 1 is part of the chain, it can be eliminated because that's the end digit in the start cell, and then the start digit is the 5, so that can be eliminated, and we're left with a naked single on the 5 in row 1 and a naked single on the 6 in row 2. So these are the solutions to these two cells. Everybody see that? Okay, let's go to the next one. Okay, once again, we've got a naked pair that lies in two houses at the same time. Row 5 and block 5, 3 and 9. And once again, our first link is going to be within this bi-value cell. We're going to start on that 9 and go to the 3. So we know this 3 is going to be a cannibalistic elimination. So then we're going to make a weak link up to this 3, strong to the 7, weak to this 7, strong to this 7, weak to the 3, and finally strong up to that 3. So the start digit is 9, and that can't be true in the end cell, and the end digit is 3, and that can't be true in the start cell. So even though that 3 is part of the chain, it's going to be false, and we can solve both of those cells for 9 and 3. Okay, we're going to do a few more because this is a really important pattern for you to learn, because with all the other AICs, we get to eliminate a candidate here and there, and once in a while we can solve a cell if it's a bi-value cell. But when they're like this, with two identical bi-value cells, you get to place two digits, and that is a really big deal. All right, next one. All right, here's our naked pair of 2 and 9. All right, I think we can start moving a little faster now, so let's make a strong link from this 2 to this 2, and then a weak link to that 1. That's a surrogate weak link. Then a strong link to this 1, weak to the 4, strong to this 4, weak to this 4, strong to the 9, another surrogate weak link over to this 9. Now don't write me letters if I forget to say surrogate weak link. Just know that we can use a strong link as a weak link anytime when making chains. And then we're going to finish up with a strong link up to this 9. So that means this 9 is false and this 2 is false. And that means the yellow 9 and the blue 2 are the solutions to those two cells. All right, let's go to the next one. Okay, here in this puzzle, our naked pair is down here in block 8. So let's start on this 2 and make a strong link to this 2. Weak, strong, weak, strong, weak, strong, weak, strong, weak, and finally strong over to this 6. So the blue 2 and the yellow 6 are our two endpoints, so you can immediately solve both of those cells for those candidates. All right, let's go to the next one. Okay, here's our naked pair in block 5, 1 and 6. So let's start on this 6, and we're going to go strong to this 6, weak to the 9, strong to that 9, weak down to this 9, strong to the 7, weak to this 7, that's a surrogate weak link, then strong up to this 7, another surrogate weak link to that 6, a strong link to this 6, and then a weak link to this 6, and finally a strong link to that 1. Now notice this last link is within this by value cell, so that means the blue 6 is going to be false. So let's draw the chain. So there's your chain, and the start digit cannot be true in the end cell, so that 6 is going to be false, and the end digit, the 1, is going to be false in the start cell. So you can eliminate those two candidates, or you can immediately enter that yellow 1 and the blue 6. All right, let's go to the next one. Okay, this time our naked pair is in row 4, 1 and 9 and 1 and 9. So let's start up here on this 1 and make a strong link to this 1, a weak to this 6, strong to the 6, weak to that 6, that's a surrogate weak link, then a strong link up to this 6, weak to the 7, strong to this 7, weak to the 9, strong to that 9, weak to this 9, and finally strong to this 9. Now I want you to notice something here. There's a turbo fish in the middle of all this. Do you see that? Now there's no 6 to be eliminated up here in row 2, column 3, but that doesn't matter. You can use this configuration to build your chain around it. That can be the foundation of your chain. That's what you want to look for, patterns within patterns. And that will help you construct these. Okay, so let's get rid of that. So the start digit cannot be true in the end cell, so that 1 will be false, and the end digit cannot be true in the start cell, so that 9 will be false. And so, of course, the blue 1 and the yellow 9 will be the solutions to those two cells. All right, let's do one more. All right, so here's our naked pair up here in block 1. It also lies in row 2. So we're going to start on this candidate 8 and make a strong link to that 6 within that by value cell. Then we're going to make a weak link down to this 6. That's a surrogate weak link. Then a strong link to the 6, another surrogate weak link to the 2, strong to the 2, weak to the 8, strong to this 8, weak to this 8, and notice we're going to finish with another strong link within this by value cell to that 6. Now the way these candidates are colored, it's a little confusing, but remember that this blue 8 in column 3 is the start digit, and the yellow 6 in column 2 is the end digit. So that means the candidates that we're going to eliminate will both be cannibalistic eliminations, and they're going to be this 6 and this 8. So let's draw the chain since this is the last one. So there's the chain, and we know that we can eliminate this red colored 6, and we can eliminate this red colored 8 and solve those two cells for the naked singles that are left behind. So let's get rid of the chain now. And we know we can solve this cell for 6 and this cell for 8. And that is how you do it. Okay, that's going to do it for today. Don't forget to click the red subscribe button and the little bell icon if you would like to be notified of new video uploads. In the next video, number 38, we're going to talk about an alternative set of rules for constructing chains and loops known as the propagation rules. but just be aware that it is not absolutely necessary to memorize them. But I will explain them to you because I think you should at least know what they are and understand how they work, and then you can decide if you want to use them or not. They can sometimes be a helpful tool that will allow you to quickly check the validity and the logic of your chain. So I hope you will join me for that lesson. In the meantime, be well and be happy.